Hello, Stallions. This is now our second day of ecology, and today we are going to go over factors that affect ecosystems, which will also include succession. We'll talk about that here in just a moment. So, um, this video is going to be mostly about abiotic and biotic factors. Now, abiotic are the non-living factors that can affect an ecosystem, such as pollution, natural disasters, and climate, along with soil. So those four things will actually affect environments in specific ways. If you go to very large cities, their air quality there is not as good. Um, Certain species of plants won't even be able to grow there due to large amounts of pollution. Climate is also another one. Our climate on Earth is starting to get much, much warmer compared to what it's been previously. Due to this, we have ice caps and glaciers that are melting. This will cause an impact on that environment up, well, where they have glaciers. So at the North and South Poles, along with some places like in Siberia, Canada, um, even in Alaska. So it is pertinent to the United States because we do have a state that happens to be right up next to Russia and Canada. So they'll feel the effects of that climate change at some point. Natural disasters. Natural disasters are a huge one, especially if you're looking outside right now. If you're watching this on, I guess this will be tomorrow for you guys. Well, tomorrow for me. It is the 26th of August. So if you look outside your window right now. There's also it's smoky, it's hazy outside. That is because Colorado has a few wildfires that are currently happening. California is going through a very similar issue with, once again, wildfires. Um, Wildfires are a good thing though, actually, to a certain degree. Um, when they occur naturally, they're going to, we'll actually go over that here in just a moment because that's part of succession. Now let's go over biotic factors. Biotic factors are living factors that can affect an ecosystem, such as the plants and the animals. They have to be living. So remember, bio means life. Okay, so biotic means life factors, whereas abiotic means non-living factors. Okay, so biotic will tell you that it has something to do with living. The A at the beginning basically turns it into the opposite, so it turns it into non-living. Um, as we can see down here, biotic factors are things like worms, trees, wolves, mushrooms. All of them are going to be biotic factors because they are alive. Viruses, parasites, all of them will also be biotic factors. Why do go back? Go forward. Okay, now we have factors that affect ecosystems. Biotic and abiotic factors determine the survival and growth of organisms and ultimately the ecosystem. Here's an example of a bullfrog. Biotic factors that affect bullfrogs would be availability of food and other species that compete with the bullfrog for food or space. Um, Abiotic factors that affect bullfrogs would be water availability and also the temperature because frogs require a certain temperature range in order for them to survive. If they're too warm or too cold, uh, they will actually die. Much like how we actually do that, but our temperature range is much, much, much larger. Um, Partially because, well, we're just bigger overall. We're much larger than a frog, so our bodies are a little bit better suited to retain temperature, and the fact that we're warm-blooded too, which helps us big time. Now, can you think of any other examples of biotic or abiotic factors? So I want you to pause the video. I want you to think about any other examples of biotic or abiotic factors. Okay, so you should have taken a few moments to think of any other biotic or abiotic factors. Other biotic factors would be maybe the availability of a mate. So is this bullfrog going to be able to have well, is it going to be able to have offspring? That's a biotic factor, okay, because, well, hold on. Now, abiotic factors, um, it could be water availability and temperature are really the big ones. But anything that is not living that is going to factor this bullfrog. So pollution in the water. We could have, wildfires, for example, natural disasters. If there's a natural disaster that goes through where this bullfrog is living, this bullfrog is either going to die or it is going to have to migrate to a different location to try to survive. That is an abiotic factor that is going to affect that ecosystem in a very specific way. Now, let's talk about a habitat. A habitat is a place where a particular population lives: anthills, squirrels' nests, beaver dams, marshes, etc. Habitats include both abiotic and biotic factors. Okay, so right here we have a anthill, here we have a nest, and here we have a beaver dam. Each of these houses a very specific organism. This nest right here, it could be a squirrel's nest or it could be a bird's nest, but it will house that particular organism in that particular area. These are all habitats. Now, how do ecosystems form? Though it may not appear this way, ecosystems are constantly changing. So, they change through a term called succession. It's a regular progression of species of replacement over time, or ecosystems evolving. Succession is slow, but natural disasters or human disturbances can make sudden changes. Let me pull that out, Mom. Handy dandy stylus real quick, and let's look at this graph, because you guys will definitely be tested on a graph that looks very similar to this. So let's go over it. Now here, at the very left, is our area. It is our ecosystem that actually has nothing living there right now. So this is going to be our first part, which is going to be bare rock. So 1 is bare rock. Notice how it's 1, 2, 3, 4, 5, and 6. There's 1, 2, 3, 4, 5, and 6 down here. Going back. And 1, 2, 3, 4, 5, and 6 up at the top. So ecosystems start as bare rock. As time increases, the amount of bare rock is going to decrease because we're going to see an increase in mosses and grasses. Okay, so this is where 2 is. Now, as the bare rock decreases, it's never fully going to go away. So if we look at this right here, it's going to approach 0, but then never actually decrease to 0. Okay, it will never absolutely hit 0 because there will always be some bare rock that will be available. Same thing with the mosses and the grasses. If we look right here, as time increases, the amount of moss and grass increases until we're right up here at its peak. Okay, right here. Now, when we're at its peak, it will decrease, and then notice once we end up over here at the end, it starts to increase again, which is kind of interesting. The next part that we have is we have grasses and perennials. Perennials are plants that come back every single year. They could be flowers, they could be shrubs. Any plant that comes back yearly is called a perennial. And then grasses, once again, will be involved with that as well. Now notice, perennials and grasses don't actually start coming around until mosses and grasses are at its peak. So it starts right about here, and it will reach its peak right here at 3. Now if we look down here, that is kind of what it'll look like. If you look at it, okay, there are no huge trees yet. There is no huge amount of growth. It's just very, very, very small, low to the ground kind of plants and things that are growing. Shrubs, trees, well, not trees yet. Trees will come later. So we just did number 3. Now we're on number 4, which is woody pioneers. These are going to be, once again, smaller trees, smaller shrubs. They'll come around right as, once again, grasses and perennials are at its peak. Now this one, notice how it gets up there quickly and then it dissipates, not actually all that fast. It just kind of decreases because once we get to, I say a lot, I apologize. Once we get over here to our climax forest, this area, these trees will take over most of our woody pioneers, and the amount of them will decrease over time. After that, we have fast-growing trees. These will be they will sprout up very, very, very quickly. They won't get very tall, but they will grow very fast and allow for a little bit of shade within that area. So and a little bit of shelter for animals too. And then the last one, obviously, being the climax forest. Now, if we look at that right here, that's the black line going across the bottom. Okay, so it's nothing, 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 and then as soon as our fast-growing trees is at its peak, it is going to increase. Because 5 and 6 are our last two, are the last two, well, numbers obviously, but they're the last two steps steps in stages, I guess that's what it says right here. Stages in succession. They will have the most amount of plants in that area, and then you can kind of see what it'll look like down here. Primary succession on land. Succession that occurs where no soil previously existed is called primary succession. The first species to populate the area are called pioneer species. Okay, so examples of this are a receipt. I don't know if y'all can hear that. That was the little voice in my room is what we're going to call it. I apologize. Let's keep it going. So, receding glaciers, as glaciers melt, bare rock underneath is going to be exposed. Volcanic eruptions are a very good example of this, because when a volcano erupts, it can actually create new islands. And these islands can become inhabited with species over time. Now, this takes many, many, many years. So, let's go down here. Lichen is a common pioneer species made up of alga, and fungus. Lichen can grow on rock and release acids that help break down the rock into soil. When lichen dies, they will leave behind organic material that plants can use to grow. So, for primary succession, lichen is going to be very, very, very important. Any pioneer species is going to be very, very, very important. Without a pioneer species, there won't be an ecosystem in that area. It will just remain as bare rock. So some kind of a species has to come along, and it has to populate the area, and it has to get this process going, because this process takes a long time. It takes many, many, many years, hundreds, thousands even of years before we end up with these very big trees in the climax forest. Now we have something called secondary succession. This is succession that occurs in areas where soil exists but has been damaged or disturbed. It is a change to an existing community that does not affect the soil. The best example of this is after forest fires. Forest fires actually, because they burn down the trees, so as we can see here, here's our tree, here's our forest, okay? Notice how there's no fire yet. We insert fire right here, and all of a sudden we get a burnt down forest. When this happens, that ash and all of that is going to end up down in our soil, which is actually very nutrient dense. After a fire, the soil becomes very nutrient dense due to the ash and that kind of stuff that just seeps down to the ground. When the water comes, it'll start this secondary succession. Because there was soil here, because there was once, they're no longer alive, or maybe they're just kind of hanging on. But in this area right here, most of these trees now are dead because they were burned. Once all that burnt ash, and once the fire stops, and once all of the ash and everything is settled into the ground, water is going to come, and it is going to fertilize this nutrient-dense soil, which will then be able to start regrowing again. So actually, wildfires, ones that are truly wildfires and not set by people camping or someone flicking a cigarette butt out a window and starting a fire, when these fires happen, naturally, they're actually very good for that given environment. It's very destructive, and it causes animals to move out of areas, but it will make the area healthier in the long run. Obviously not the time, because it destroys it, but it's one of those things that you have to destroy it in order to make it better, and it makes the whole ecosystem around it much, much, much better when it happens naturally. This is regrowth after the forest fire and secondary succession. And then that's the end of day 2.